Okay, in this video we're going to be talking about tree diagrams and area models, but we're going to go a little more in depth than what we've gone in the past. So I basically titled this video More Background Info to Tree Diagrams and Area Models. Let's get started. Alright, you've seen a tree diagram before, okay? Now what makes this tree diagram different is the fact that now I have given you information, but then there's also information I want you to find. So like for example, I need you to find X, Y, Z, and also W. Okay, so that's what we're going to do here. If you remember back to the other videos, if I was to have a tree diagram such as this, and if I was to, let's say if I was working through the tree diagram, and I'm just going to highlight my route here, I went here and I went down here. Well, naturally what you would do is you would take the percentages for each branch that you went through, and then you would multiply them to get your overall probability of that particular situation. Now, in here, we're kind of working backwards where we already have our overall probability, but we just need to find what this branch is here, okay, which is Y. Now, I'm just choosing Y just because I wanted to work with Y, for example. If you wanted to start with X, feel free, you can do that, but I'm just going to go ahead and do Y. Now, remember that we have to multiply zero point 0.8 and y to get 0.56. So we have to multiply. So if we're working backwards, we would have to divide. So in my mind, I'm thinking this. 0.8 times y is equal to 0.56. All right. Simple division. Y is equal to 0.7. All right. So that means this y is going to be equal to 0.7. All right. Now, here's what's great about tree diagrams. If you remember from a previous video, whenever you have a branch off, so like right here, if I see how I branched off right here, notice that all of my percentages when dealing with the branches will always add up to get to 100%. All right, then that's going to help us out a lot because if you already know y is 0.7, well, x would have to be 0.3 because both of these two numbers add up to get to 100%. So that's actually one step saving measure you can do if you want to call it that. All right, so let's move down to this right here. Finding Z. Well, finding Z, I know I wrote all over my tree here. Let me kind of clean this up a little bit. All right, to find Z, well, that's actually a step below what we've been working on because it's easy here. 0.2 times 0.6. Well, that's pretty simple. We've done this before. That's going to give us 0.12. All right, now we got to find W. But in order to find W, notice that we need to find this right here. But going back to my whole all branches equal 100% deal, I know that this is going to be 0.4. So 0.2 times 0.4 gives me 0.08. Now to check to make sure that you're correct, after you did all your multiplications, all your products here, if you were to add all of your products up, if they don't equal 100%, you did it wrong. So 0.24, 0.56, 0.12, and 0.8. So does all that add up to get to 100%? It does. So I know I did everything correct. Let's move on. All right, here's another one. Now here, I'm going to give you the opportunity to do this yourself. So I'm going to ask you to pause the video if you want to do it, and then I'll come back with the answer. So pause in 3, 2, 1, pause it. All right, welcome back. Now, working off of this tree here, I'm going to go ahead and solve for the stuff that's super easy. That's 0.8, so y would have to be 0.2 because remember all this equals 100%. If this is 0.6, this would have to equal 0.4 because remember all branch offs equal 4%. Now I'm going to go ahead and solve for y here. I'm sorry, x. So that is 0.8 times x is equal to 0.72. And if you didn't see what I did here, I was going this route here. X 0.8 equals 72. All right, so when I solve for x, I end up getting, if I'm not mistaken off the top of my head, 0.9. Now, if x is 0.9, r has got to be 0.1, because remember, all this equals 100%. Now, 0.1 times 0.4, that gives me 0.04, but I forgot about S here. 0.9 times 0.2, that gives me 0.18. If I was to add all these numbers up, remember, if you don't get 100, you are messed up, and it does not work. Not saying you're messed up, but the problem got messed up here. And so that works out. Awesome. So those are our tree diagrams. Let's go into area models here. Okay. Now, we've talked about area models when they were already created for you. All right, so now we're actually going to create the area model itself with a different situation. It says here that 60% of the students have dark hair, 20% of the students have curly hair. All right, and there were 30 students that were surveyed. Now, we're not going to worry about the 30 students. We're going to leave that off to the side here just for a moment. All right, now here I wrote a little hint. Since you have two different types of hair, make one option on the x-axis and the other on the y-axis. Now, if you remember, going back to our days of geometry or algebra plotting points, this right here is your x-axis. And then, of course, the vertical line would be your y-axis. All right. Now, just pure choice here, I'm going to make the dark-haired people be on my y-axis, which means my curly, and I'm writing with my mouse again, so it's going to look weird, on my x-axis. Now, there's going to be values on each of your axes, or this is going to be the 0%. This is all the way going to, and over here is going to be 100%. See, I have a little scale thing going. So that's 0 to 100% here. Same thing for my y, 0 to 100%. And that's going to help us out. So let me clean the table up, get rid of these words here. All right. Now it says here, 60% of the students have dark hair. All right. So what I'm going to do is, excuse me, I'm going to, on my y-axis here, I'm going to go up to where I believe 60% would be. So there's 0, there's 100, so somewhere a little above, I'm just going to say there. There's my 60% mark. All right. So my 60% mark is right here. There's my 60%. Now, just to kind of go a little more in depth, the percentages will also be my dimensions for my little rectangles I'm drawing in here. So what that means is, since I went up to 60, the dimension from this here would be 60, okay? Which means the dimension for this top square would be 40. And that's going to help us out a lot because we're eventually going to have to find the area. Now, what I'm going to do is I'm going to shade, and what that means is I'm shading everybody that has curly hair. So I'm shading the curly haired side. So there's my curly haired side. Okay. I'm sorry, I said dark haired. Sorry about that. Dark. All right, so this is my dark hair. All right. And for lack of a better word, this is going to be my non-dark hair. Okay. Now, the next thing we got to do is 20% of the students have curly hair. So my curly haired folks, I'm going to go on my x-axis, and so I would say 20%. Let's just say it's right there. All right. So on the left-hand side of my vertical line that I drew, these would be curly, and on the other side will be non-curly. All right, and so if you notice, you have created 4 different little spots inside of or 4 different rectangles in your area diagram, or area model. So I'm going to go ahead and shade all my curly haired folks. And if you notice, I'm actually going over this spot twice. This box right here, and I'll use a pretty color, we'll just say blue. Let's see if this works. Oh, there it is. It's not really blue, but so if you notice that we have some overlap, okay? So this overlap right here represents both curly hair and dark haired, okay? And so what I'm going to do, I'm going to have to stop the video and I'm going to have to create another one. So I'm going to call this part 1 and then tune into part 2 to finish this up. Thank you.